Hey everybody, welcome to Math with ACE, focusing on statistics. We are continuing to explore examples with probability, looking at sample spaces and determining events, outcomes, and their probabilities. This question is about fair coins, and we're finding the probability of the events. Now, in a previous example, we had listed the sample space. So if we're flipping two coins, the options are heads and tails on the first flip. And on the second flip, it's also heads and tails. So if you look at the outcomes, we have heads, 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 tails, tails, heads, and tails, tails. So in the sample space, here are our outcomes. F is the event of getting at most one tail. So listing the events, at most one tail is heads, 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 tails, tails, heads. I can't do tails, tails because that's more than 1 or 0. And that probability of F is equal to 3 of those outcomes out of the 4 in the sample space. Probability of G says the event of getting two faces that are the same. Now, faces is a little bit deceiving because you think about the fact that head is a face. That's the way that I think about it. But what they're saying is, what are two flips that are the same? So the probability, the outcomes of G would be heads and heads are the same. And then tails and tails were also the same. They have the same outcome twice. And the probability of that happening is 2 of those outcomes out of the 4 in the sample space. H is the event of getting a head on the first flip and then followed by a head or a tail. So it doesn't matter what happens on the second flip as long as I get a head on the first flip. So H outcomes is heads, 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 tails, and then tails, heads doesn't have a head first, and tails, tails doesn't have a head first. So the probability of this happening is 2 out of 4. And then the question is whether F and G are mutually exclusive. So let's look back at F and G. So F was heads, 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 tails, tails, heads, and G was heads, heads, tails, tails. Now, mutually exclusive is if probability of F and G is equal to 0, meaning they have no shared outcomes. So is there anything in F that's also in G or vice versa? And if you notice, the very first thing of heads, heads is in both of those. So there is something shared by both, which means they are not equal to 0 and they are not mutually exclusive. Okay. J is the event of getting all tails. The outcomes then are TT. And I want to know if, then that probability, just for fun, is 1 out of 4. If J and H, well, H was HH, HT. TT is not in H, and HH and HT are not in J. And so J and H are mutually exclusive. So yes, since the probability of J and H equals 0, they are mutually exclusive. Okay, let's move on to our next question. Dealing with complements again and mutually exclusive, and now we're adding in conditional probability. So we're rolling one fair six-sided dice, which has the side six-sided die, which have the sides 1, 2, 3, 4, 5, and 6. A is the face is odd. I'm going to go ahead and list those outcomes. If it's odd, it would be 1, 3, or 5, which is listed down below. And then B is even, so B is 2, 4, and 6. Find the complement of A prime. So A prime is everything that is not in A. 1's in A, but 2 is not. 3 is in A, but 4 is not. 5 is in A, but 6 is not. So A prime, the complement, is the same as B. And that probability, even though it doesn't ask for it, is equal to 3 out of the 6 total. Let C be the event where the odd faces are larger than 2, and D is all of the even faces smaller than 5. Are they mutually exclusive? Okay. Looks like we have a duplicate question here, but listing C, odd faces larger than 2. Okay, 1 and 2 don't count because they're not larger than 2. 3 is odd, that's good. 4 is not odd, so it doesn't count. 5 is odd, that counts, and 6 is not odd. D is all of the even faces smaller than 5. Okay, 1 is not even, 2 is and it's smaller than 5, 3 is not even, 4 is and it's smaller than 5, and then 6 is not smaller than 5. Are they mutually exclusive? They don't share anything. 3 and 5 are not in D, and 2 and 4 are not in C. So yes, they are mutually exclusive, which is actually the same question as 7. Nope. Yes, because the probability of C and D is equal to 0. They have no shared outcomes. Event E is all faces less than 5, which means 1, 2, 3, 4 are my faces because 5 is not less than 5. That probability is 4 out of 6. So then I'm asked if C and E are mutually exclusive. If you look at C, C has 3 and so does E, which means the probability is not 0. They actually share something in common. So no, because the probability of C and E is not equal to 0. 3 is in both. Now, finding the probability of C given A, which is a conditional probability. And the way that we calculate this, if you recall the formula, the probability of C given A is found by taking the probability of C and A and dividing that by the overall probability of A. We need to calculate some probabilities here. C and A, let's list those events first. A is 1, 3, and 5, and C is 3 and 5. So 3 and 5 are both in A, so C and A are the numbers 3 and 5, which has a probability of 2 out of the 6. The probability of A is equal to 3 out of 6. There's 2 ways that you can calculate this. You can look at this as by taking 2 out of 6 over 3 out of 6 and dividing the fractions, which actually means you take 2/6 times 6/3, reduce, and you get 2/3. Or you can look only at A. A has 1, 3, and 5. Of those 3, how many are in C? 2, which is 2/3. So using the formula and calculating it with fractions is the same as looking at the condition and determining out of the total in the condition how many actually meet the and. Hopefully this was helpful. Let's take another look at some more examples in the next video.